Learn how to protect your APIs from modern security threats. In this course, you'll explore the OWASP API Security Top 10, analyze actual API breaches, and master the essential 3 pillars of API security. Whether you're a developer or security professional, you'll gain practical knowledge to build and maintain secure APIs in today's threat landscape. Dan Barahona created this course.
Hello, freeCodeCamp community, and welcome to API University and this course on API Security Fundamentals. My name's Dan Barahona, and I'm one of the co-founders of API University. It's a site where we provide dozens of free API security courses, webinars, and conferences, and have over 100,000 students enrolled. In this course, you'll learn all about why attackers are targeting applications and exploiting flaws in their APIs. We'll cover the entire OWASP API Security Top 10, including real-world examples of each one, and then provide practical guidance on what organizations can do to keep their applications secure. At the end of the course, you'll have an opportunity to take a final quiz and earn your certificate and badge. Thanks for watching, and I hope you enjoy the course. Hi, and welcome to the API Security Fundamentals course. We created this course to raise awareness about API risks, share some best practices to help you keep your APIs secure, and provide a foundation for building a strong API security program. Now let's talk about what we're going to cover in the course. We're going to start with why API security. Why are we talking about API security? Why do attackers find APIs so appealing? And we're going to explore how APIs are being attacked and why they're being attacked. Well, they're going to go through the OWASP API Security Top 10, and we're going to share a number of real-world breach examples that highlight the OWASP Top 10. We'll then do an analysis of API attacks and really try to identify those primary drivers of breaches and where the root causes of vulnerability are coming from. We'll then talk about what you can do to better protect yourself. This is a section we call the 3 pillars of API security. And we're going to talk about governance and testing and monitoring and different approaches for API security. And then we'll wrap up with some best practices, some really tactical information to help you keep your APIs secure and safe. Let me tell you a little bit about API University. We created this site back in 2022 to help educate the community on the risks of APIs and how to keep them secure. We definitely hit a nerve as we have over 100,000 students now enrolled in these free courses. I'd love to invite you to check out apiSecUniversity.com, where you'll find additional courses on topics like API pen testing, the OWASP API Security Top 10, API security for PCI compliance, API documentation and authentication, API gateways and product management, and we're adding more all the time. We also provide free certificates for completing these courses. You can even earn your API Security Fundamentals certificate for the course you're taking right now. At the end of this course, you'll get a link where you can take our final quiz and receive your certificate and badge. I hope you'll check out more of our courses. But before we get any further, let me tell you a little bit more about myself. My name's Dan Barahona. I'm one of the co-founders of API University. Been in the cybersecurity industry for over 20 years. I've led products teams, marketing teams, sales teams, and have held C-level roles at companies like Qualys, ArcSight, Anomaly, and currently at APISec.ai. I have engineering degrees from Rensselaer and Cornell University, an MBA from Michigan, and very much love to keep in touch. So if you want to reach out to me, there's my email address, there's my LinkedIn profile. Please don't hesitate to reach out. Now let's get on with why API security next. So next up, let's talk about why API security is such an important topic. But to get started, let's first talk about what APIs are. If you're not familiar, API is Application Programming Interface. Some people call APIs websites for machines. But if you think about it, APIs actually are present in almost everything we do online these days. Here are a few examples. Let's say you're searching on Google for directions to a restaurant, and then you want to book a Lyft ride or an Uber ride. How does that communication happen between Google and Lyft? That's all being done through APIs. Or if I want to send money to my barber from my Wells Fargo account, how does that happen? Well, Venmo is actually communicating with my bank through APIs as well. Or if I want to check airfares on Kayak across multiple different airlines, it's fetching that information through APIs. So APIs are really powering how the internet works these days and have really enabled some really fantastic capabilities and integrations across organizations and within our applications, our mobile apps, and the like. Now, let's paint the picture of what's going on out there in the real world. And I call this the perfect API storm. So let's go through a few statistics. The first one is 83%. And this is what percent of the internet's traffic is API powered. This is a study that was conducted by Akamai a number of years ago. And they found that 83% of the traffic on their networks was API powered. And this is really a testament to how great APIs as a technology have been and how pervasive they are now, right? They really are powering virtually every website, mobile app, and the like. But number one is where API attacks now rank. This is a quote from the Gartner Group. They predicted a number of years ago that API attacks would become the number one most frequent attack vector. And you will see here that has certainly turned out to be true. And 4%, unfortunately, kind of represents the state of our API security. This is a survey done by Rapid API, now owned by Nokia. And they surveyed their millions of users what kind of testing they're doing on their APIs. And 96% of the responses were positive testing. Right, making sure it works properly, it's bug-free, performs, integrates, and only 4% of respondents cited security testing on their APIs. There's a reason why that number is so low, but we have to do better, and this is creating a perfect storm for breaches and attacks to take place. And let's look at what's being stolen out there. APIs are connecting to data, transaction engines, personal information, corporate intellectual property. And there are a number of things that attackers are looking for, right? They're looking to steal credit card information. They're looking to steal personal information. They're looking to perform fraud. They're looking to scrape data. APIs are really a very attractive target for attackers for all of these reasons. And this is really the tip of the iceberg, as you will see. But why specifically APIs? Like, what is it that makes APIs so appealing? And this very simple graphic really paints the picture, right? If you look at where API sits, they are the glue, the connective tissue that make the internet work. Every time I log into my bank account, there's an API call. If I want to deposit a check, that's a different API call. If I want to transfer money, a different API call. So APIs sit here right behind all that application functionality, and they enable all this to happen seamlessly. It connects the outside world to our internal applications, databases, transaction engines, and such. And if there are any flaws in how those APIs are configured, the logic behind them, how they are set up, those flaws can turn into vulnerabilities and exploits. Right? And one thing I want to address right up front is this notion that APIs are kind of hidden and invisible and we don't need to worry about them. And we see far too many breaches occur for exactly that reason. So let me show you just how easy it is to find these APIs. Here you can see I've simply gone to United Airlines. I'm looking up some fares and flight times. And to find the APIs powering this interface, it's really quite simple, right? And United hasn't done anything wrong here. I'm not picking on them. I'm merely showing you how easy it is to find these APIs. All I have to do is within my browser, right-click, click on the inspect button, hit the network tab, and there you go. You can see this API called Fetch Flights. And I can actually see the payload and understand the entire construction of that API request. As I say, there's nothing wrong with this. My point is simply these APIs are not hidden. They're actually quite easy to find, and this is exactly what attackers are looking for. Now let me show you how virtually every API attack takes place. What an attacker will do is they'll come to your site, they'll create an account, they'll install your mobile app, they'll utilize every feature and function of your application. Right? And they're going to look for those API calls in the traffic. They're going to monitor that traffic. They're going to search for those API calls in the traffic. And the next thing they're going to do is go around your UI and hit those API calls directly. Now, the reason why is if you think about your UI, it's a very controlled, locked down environment. right? I can only see the data that you show me. I can only click on the buttons that you present to me. It's very controlled. But the API layer is completely uncontrolled. And what I mean by that is it's just a command line, right? And I can write any request I want and send it. Nothing's going to stop me from doing that. And we're now relying on that back end to know if that request is legitimate, malicious, or anything else. And what attackers are looking for at that API layer, and what they often find, are APIs that are over-permissioned. They have access to more data, more functionality, more features than we expose necessarily in the UI. And they also expose logic flaws that might not be exploitable in the UI either. And this is the fundamental reason why APIs are such a ripe target for attackers. Now, another reason why APIs are so appealing is if you look at how easy it is to perform these exploits. Let me just show you what kind of the classic cyber attack looks like. We call this the kill chain. It's a very complex multi-step process from performing your reconnaissance, infiltrating, weaponizing, moving laterally, escalating your privilege, and finally exfiltrating and causing that breach to happen. That takes a high level of sophistication that most attackers don't have. On an API attack, though, this is what it looks like. Your attacker is going to poke around and probe and try to find a vulnerability in your API, and once they've found it, they can go straight to breach. And you will see many such examples here in the upcoming sections. It's a far simpler attack pattern for attackers. So this is another reason why APIs are such an appealing target. And the regulators have very much taken notice of APIs. You can actually see here an example of a breach at T-Mobile where 37 million subscriber records got exposed through unauthorized access to an API. They had to file an 8K filing with the SEC to report this incident. And here from Verizon, who owns TracFone, the Federal Communications Commission handed down a $16 million fine when they completed an investigation into subscriber data being leaked out through APIs. And beyond the fine, they actually mandated a number of API security best practices. And as you can see here, they must now perform continuous static and dynamic security testing of web apps, prioritizing APIs with automated tools to test for vulnerabilities. This is one of the best practices that we're going to talk about in this course. The need to pressure test our APIs proactively and continuously to find those vulnerabilities and remediate them. Now, there are a number of other regulations out there that are really paying attention to APIs as well. The payment card industry, PCI, actually has a new DSS, Data Security Standard 4.0, that became mandatory in 2024. If you look at this PCI requirement, it has API security written all over it. Things like looking for business logic abuse, abuse of APIs, training for developers on API risks and the like. You've got GDPR and really any privacy initiative out there. If your APIs are touching personally identifiable information or healthcare, PHI, protected health information for HIPAA, those APIs are very much in scope for your auditors. The SEC has a new regulation that's best known for its 4-day breach notification requirement. But publicly traded organizations now have to report their security programs, including any risks to APIs. The United Nations has a whole cybersecurity requirement for automotive manufacturers and suppliers. And as we know, connected cars are all powered through APIs these days. Right? When I unlock the doors or turn on the air conditioner from my phone, it's all API calls going to my vehicle. FedRAMP in the U.S. government, if you want to sell and provide services, cloud services to the U.S. government, they have mandated monthly web application security vulnerability testing, including APIs, right? And what does it all boil down to? All of these regulations. There's really three aspects to these regulations. One is security, which is really to ensure the secure operations of our infrastructure, our applications, and so forth. And so we need to make sure where we have APIs that they are being set up, configured, and operated securely. Then you have a privacy requirement, for example, with GDPR or CCPA in California or PIPEDA in Canada or many others, to protect the data of individuals. And if your APIs have access to any such information, then they're very much in scope for your threat modeling and your risk profile. We've got to make sure that we're addressing API security when we're looking at how to protect this regulated information. But then we have a competing requirement, a data accessibility requirement, right? So for example, in HIPAA or in banking, there are requirements to protect the data, but there are also requirements to make that data portable and accessible. And what that really means is it's mandated on organizations to utilize APIs to enable integration and data transfer. But we have to make sure that data transfer happens securely. Okay? And that wraps up the why we're talking about API security. In the next section, we're going to go through the OWASP top 10, and we're going to go through a number of real-world breach examples and explain exactly how those attacks took place. Okay, in this next section, we're going to go through the OWASP top 10 and share some real-world breach examples to reinforce the learnings and the requirements of the OWASP top 10. Now, if you're not familiar with OWASP, it is the Open Worldwide Application Security Project. It is a really fantastic organization, a nonprofit that produces some of the best guidance out there for application security. And they actually are best known for their OWASP top 10 for web applications. And back in 2019, determined that APIs have their own unique threats and risks and really deserve their own top 10. And they came out with the OWASP API Security Top 10. And in 2023, actually updated that to a new generation of the top 10. There were some additions, some changes, some deletions that occurred between 2019 and 2023. But we're going to cover the 2023 edition here in this course. Okay. Now, here's what the top 10 actually looks like. And rather than go through these line by line, what we're going to do is break each one of these out into its own separate submodule. And we're going to describe what they are. And we're going to then provide an example to demonstrate that risk vector and then provide some best practices and guidance. Okay? But to get started, I want to share with you what's happening out there in the real world. And what we're seeing in the real world is really just an enormous volume of successful API attacks and breaches and exploits. What you see here on this screen is just simply a small sampling of publicized API attacks that have taken place. And what we're going to do is take a look at a number of these and map them to the OWASP top 10. And what you're going to see is a number of different threat vectors. We're going to see things like unauthorized trading. We're going to see account data harvesting. We're going to see data exposure. We're going to see takeovers, tampering, reputation risk, ransom, and third-party exposure. And what these attacks are really highlighting is that there's something about API attacks that are getting through the defenses. All of these companies were employing the best practices. They all had web app firewalling. They were doing their source code scanning and dynamic testing and pen testing and all these things. But something about API attacks is getting through those defenses. And that's what we're going to explore here in the rest of the course. And first, we're going to start with OWASP number 1. Okay, let's start with OWASP number 1. This is known as Broken Object Level Authorization. You'll hear it called BOLA quite a lot. It's number 1 for a good reason. It was number 1 in the 2019 list and also in the 2023 list. It's one of the most dangerous and difficult to detect threats. And the classic example of BOLA is, can user A access user B's data? Or can a user perform an action on an unauthorized object, right? These are authorization flaws, and they're quite difficult to detect in runtime. It can cause very significant risk of data loss, as you will see. It can cause fraudulent transactions, as you will see here as well. So let's share an example or two here. And the first example that I want to give you is from Coinbase. And here there was a researcher, a hacker, who wanted to poke around the Coinbase platform and see if they could find any flaws. Right? And like I mentioned earlier, the first thing they did was they came to the website, they created an account, they deposited some money, and they started utilizing all the features and functions of the Coinbase platform. Meanwhile, looking at all the API traffic. And what you see here in this screenshot is what that traffic looks like when you do a trade. And you can see the elements of the trade here in the yellow boxes. The quantity, the price, You can see here the product ID. That's what was being transacted here. In this case, this hacker was selling their Ethereum on the European market. And then you can see they're on the sell side and their various accounts. Okay, this was a valid request. They actually owned this asset, and this would have processed just fine. One of the techniques that attackers like to use is to send intentionally erroneous requests in order to see what kind of error messages come out of your server. Many times our error messages can not only be useful but revealing. And so he wanted to get an error message, so he took this request, which is a perfectly valid request. He owned this asset, and he backspaced over the Ethereum, which he owned, and he typed Bitcoin on the US market, which he did not own. And he hit submit and waited for the error message to come, because clearly that transaction should not get processed. He didn't receive an error message. What he got back was a trade confirmation. And as you can see here down below, his $1,060 of Ethereum sold as $43,000 of Bitcoin. And much to his shock, I'm certain, did not expect that to get processed, probably thought he might be going to prison, and instead went on to x.com and posted about this potentially market nuking vulnerability, and could anyone get him in touch with the CEO. Coinbase gets an awful lot of credit in my book. The CEO himself actually responded. They shut down the market. They were able to fix the issue within a matter of, I think, a day or so. And a week later, they actually shared what was the root cause of this vulnerability. And what they said was there was a missing logic validation check in their brokerage API endpoint. And what that effectively means is that their application was checking the price, the quantity, but was not validating the asset ID, the Ethereum or the Bitcoin in this case. It just assumed whatever he was trying to sell was the asset that he actually owned. And that's the missing logic check, right? So one of the takeaways from this example is that your UI is not part of security. In this case, there's no way this attack could have taken place in the UI. The UI prevents that type of abuse, that type of manipulation of the logic. But at the API layer, as you can see, that was entirely possible. So we often rely on the UI as kind of a band-aid, a cover for maybe some weak or missing logic that we might have. But as you can see, if the attacker can go around the UI, they can go around all those controls as well. So we really need to secure right there at the API layer. The next example I want to share with you is from Peloton, the exercise equipment company. Here there was another hacker, a researcher that looked around the Peloton application, found all of these APIs. Quite a number of them were unsecured, meaning you could utilize these APIs without providing any credentials. And one of these API endpoints had access to the entire 4 million user Peloton database. And so they actually notified Peloton of this exposure, and Peloton then took action and fixed the issue, right? They took that unsecured API endpoint and locked it down. You can no longer query it anonymously. You have to have valid credentials in order to access this API. But the problem was anybody could go create an account on Peloton and utilize those credentials and access this API and still access 4 million users' records. And this is the difference between authentication and authorization. They addressed the authentication issue, which is Dan actually Dan? But they did not address the authorization issue, which is, can Dan access other Peloton users' records? Now, both of these examples, Coinbase and Peloton, are great examples of OWASP number 1, broken object level authorization, and really demonstrate the risk that comes from not having properly configured authorization logic in your applications. So what are some of the best practices? Well, really, we want to move security as far left as possible. So when you're in the design phase for a new application or new API, let's make sure that security is in the room at the whiteboard, bringing their concerns and requirements to the product needs. Let's review those requirements. Let's understand what data the APIs are going to touch, what data they're going to have access to, and make sure there's logic, there are controls in place to prevent this type of cross-account contamination. Then you want to enforce those controls and test those controls to make sure that they're actually working as designed. And these are the types of things that really need to be implemented during the software development phase and can't really be addressed in a web app firewall or some sort of runtime rule. So it's really critical that we address these types of authorization flaws up front. Okay, next up is OWASP number 2, broken authentication. This is really defined as weak or poor authentication on our APIs. It could be no CAPTCHA, no two-factor authentication, brute forcing, credential stuffing, and these types of things. What we often find is no authentication. Quite a few API breaches are happening because APIs are left completely unsecured with no authentication whatsoever. And of course, the risks are obvious. If we've got poor or missing authentication on our APIs, that's exposing whatever that API has access to. As we saw already at Peloton, they had an unsecured API that had access to all of that user database information. This could lead to data harvesting, could lead to abuse of your APIs through unauthenticated requests, ransom, PII, personally identifiable information harvesting, and the like. Now, the example I want to share with you here to demonstrate this is from Duolingo, language learning app. I imagine many of you taking this course are Duolingo users. I myself am a Duolingo user. And as you can see here, over 2 million records were exposed through an API. And here there was another hacker that poked around the Duolingo platform, found a number of APIs powering this application, and quite a number of them left unsecured, meaning you could query them without any credentials whatsoever. But the way this API worked was if you supplied an email to the API, it would respond and let you know, is this an active, valid user on the Duolingo platform, and a bunch of profile data about that user. So as I mentioned, I'm a Duolingo user myself, so I tried it on myself, and this is exactly what happened. I'm not that sophisticated. Technically, I could even do this from a browser. All I had to do was to append my email address, and immediately I got all of this information about my Duolingo account, the streak, what languages I'm learning, and so forth. But the key is I could do that with any email address, my child's email, my next door neighbor's, your email, anybody's, and I could have done this as well. And this is a great example of broken authentication, an API that is left without any real controls preventing abuse or users from accessing it. Now, why do organizations sometimes leave these APIs unsecured? It seems obvious to lock them down. We know there's a lot of pressure, a lot of demands on developers to fix bugs, to hit release dates, to release new features and functionality. And there is a perception that APIs are hidden and don't really need to be worried about. But of course, as you can see here, attackers are specifically looking for APIs, right? So let's make sure that we're considering authentication in the design phase of our applications. Let's make sure we're considering what types of controls and how we need to authenticate users. And that needs to really be tailored to the sensitivity of the application. If your app is simply checking the weather, you might not need any authentication whatsoever. If I'm able to set my password or transfer funds from a bank account to another account, you really want to elevate that authentication as well. And make sure you implement continuous testing to ensure that your APIs and your applications are functioning as expected, that authentication is in place and being enforced. And please don't assume your APIs are secure just because they're hidden from regular users. They're not that hidden, as we've shown you. So let's make sure we lock the door. Okay, next up is OWASP API 3, which is broken object property level authorization. This is a merger of two categories from the 2019 edition, mass assignment and excess data exposure. Mass assignment really has to do with the ability to manipulate and modify data through the APIs in unauthorized or improper fashion. Excess data exposure reflects the risks of APIs revealing too much information, whether it's volume of information or the type of information, my personal information, my bank account information, my home address, and so forth, right? An example of mass assignment might be a user setting their account type from free to premium, right? That's an example of a data manipulation, right? Or APIs that return too much information, unnecessarily verbose information, high volumes of information. Naturally, there's a number of risks here from broken object property level authorization, which you may also hear called BOPLA. Now, the example I want to share with you is from Venmo, the payment platform. social platform. So on their homepage, they had a feature that would show you the last 10 or 20 transactions in real time, but anonymized data, naturally. So it might have my first name, but not my last name or account details. But as you can see here, this attacker found the API powering that feature of the homepage. It was a public API, no authorization required, so they could query it to their heart's content. But here's the key. When they queried that API directly, as opposed to viewing it through the UI, the API did not return anonymized data. It returned the whole record, first name and last name and so forth. And so they wrote a script and harvested over 200 million transactions out of the platform in full, complete detail. What's the takeaway here? We need to make sure we're tailoring our APIs to the use case. And there's a best practice known as data minimization, which is simply don't return a single field more than the business case requires. In this case with Venmo, they probably should have created a special API that only returned those fields that were going to be presented in the UI. Instead, they relied on the UI as a filter. The API returned far more data, but they simply filtered it in the UI. Right? In terms of best practices and prevention, we got to make sure that the API only returns the data that is necessary for that business use case. Return the minimum amount of information and not a field more. These requirements should all get defined early on in that design phase of your APIs, right? This is why we want security in the room during the design phase. So we're ensuring that the APIs are not revealing more information than necessary. And let's make sure we test our APIs. This is a great way to identify overly verbose APIs. They're very good automated tools that will look at your API responses and identify credit cards, email addresses, any other PII or sensitive information. And from the mass assignment side, we've got to make sure that we set proper controls over not only what data can users see, but what data users can manipulate. So we got to make sure we have the proper controls in our logic to prevent that kind of abuse. All right, next on the OWASP list is number 4, unrestricted resource consumption. They just changed the name. They used to be called lack of resources and rate limiting here, but really this is meant to address any kind of volumetric or brute forcing of our APIs here. Examples are pretty obvious, things like mass data harvesting, not having proper rate controls enforced on our applications, but it could be also things like lack of proper execution timeouts, or not controlling the maximum memory or number of lines returned or the upload file size. These are all examples of how brute forcing can take place on your API. And it can result in things like excessive operations, excessive data being returned, denial of service, degradation of performance of your application. So this is really one of the most important and probably most common examples of an API threat that we see out there. Now, the example that I want to share with you here comes from Trello. If I wanted to invite you to my Trello project, there's a feature where I can simply provide your email address, and a backend process will send you an invitation to my Trello project. That backend process is powered by an API. That API is publicly accessible and was unsecured. And when this attacker found this, what they discovered was they could send an email address into that API endpoint. The Trello API would reply with, is this a known Trello user, and a bunch of profile information about that user. When the attacker found this, they knew that they could harvest a lot of information, so they went onto the dark web and they collected 500 million email addresses from prior breaches, and they sent 500 million requests at this API. This is a perfect example of unrestricted resource consumption. Now, you may be thinking, shouldn't the rate limiting, shouldn't the WAF, the gateway, have prevented this type of mass abuse of the API? And those are all technologies that you should implement to prevent this type of abuse. But attackers are quite clever, and we know in this case with Trello, they had a web app firewall in place. They probably had other forms of rate limiting and bot detection. So how were they able to send 500 million requests? Attackers are clever and determined, and they probably ratcheted up their requests until they hit that rate limit ceiling and then dialed it back by some small amount and just flew under the radar. They distributed their attacks across thousands of IP addresses. They might have used residential proxies and all of these things to evade detection. And certainly this attack would have taken months, if not longer, to execute. So a determined attacker is going to find their way around things like rate limit defenses and other things. So what could Trello do about it? As you can see here, Atlassian, the owner of Trello, they made a change to their API so that unauthenticated users could no longer request the information of other users. They simply took that unsecured endpoint and they made it secure. And that was a very effective response here. And the reason why is it's far easier to detect abuse in the form of 500 million requests coming from Dan than 500 million anonymous requests. So simply by being able to associate that traffic to the source user, they could really mitigate this type of risk going forward. Okay. So what do we want to do to address this? Well, of course, we want to implement traffic controls, whether it's a web app firewall or an API gateway. But we have to understand that those traffic controls are not silver bullets. A determined attacker might find their way around it. We got to make sure we're testing the effectiveness of those controls. And we got to make sure that even if those controls don't prevent this type of bot attack or high volume brute force attack, that our APIs are not revealing information that we don't want out there in anonymous users' hands, right? So using authentication to control who can access data and what they can see is really critical here. All right, OWASP number 5 is broken function level authorization. And it's what we saw with OWASP number 1, broken object authorization, except instead of looking at what type of data a user can access, here we're talking about what type of functions they can perform. So it's an abuse of functions. Are there transactions? Are there capabilities? Like being able to reset someone's password. That should only be possible on my account, not on your account. So you have to control not only the data users can access, but the functionality that they can access as well. We'll often see things like replacing passive methods on APIs like get, which are really lookup type methods, with active methods like put and post and delete. And the risk is quite obvious here. The ability to perform functions like escalate your privilege, convert my free account into a premium account, modify other types of account information. I could also do things like delete an invoice or set my car loan balance to 0 or to a negative number. It's really crucial that we are controlling what functions users can access and with what permissions. The example I want to share with you here comes from Bumble. This is a very popular dating application. And on Bumble, there are 2 user types. You can have a free account or a paid account. And there's an API where you can look up what account you have, what account type you have. That is called a GET request. Just tell me what type of account and it will respond with free or paid or whatever account type you have. But they also exposed a function to modify that. Maybe it was a post method on that same endpoint. So not only could I look it up with a GET request, I can modify it with a post request, right? And say, change my account from free to paid. And that's exactly what happened here at Bumble. And so anyone with the cleverness to know how to use that API, they could simply elevate their account without ever making payment. Now, that elevation of a user account should only have been possible by requiring the user to provide their credit card and completing a transaction, and then a back-end process would elevate the user. This is a function that should never have been exposed to the end user. So this is the authorization flaw. The user should not have access to that particular function. So in terms of prevention here, we need to identify what those functions are, what those methods are, what those endpoints are that are performing sensitive actions, and make sure that we have the right logic and controls in place to limit access, to prevent users from accessing those functions and performing some sort of malicious or inappropriate or abusive type of request. So another great opportunity for testing, we want to test the permissions of every user type against all of our endpoints and identify any gaps or overlaps or areas where a user could access a function we don't want them to have access to. This is where RBAC, role-based access controls, comes in. We got to make sure we're testing all of those different roles across all of our different endpoints to ensure that there isn't any drift or changes in our permissions that we don't know about that can create this type of exposure as well. OWASP API number 6 is actually one of, I think, the most important additions to the 2023 top 10. It's unrestricted access to sensitive business flows. And why I really like this is it introduces the concept of business flow, business logic. And as API developers, as application operators, we tend to think about, does the application work as designed? Can I purchase that sneaker or book the vacation or transfer money or all of these things? We want to make sure it works as designed. But what we're talking about here is, can that business flow be manipulated? Can it work as not designed? Can it be misused or abused? Here we're typically going to see an abuse of a legitimate flow in ways that wasn't intended. Often we're talking about excessive use or some sort of automated abuse of that business flow. And this is almost always the result of some kind of logic flaw. There's a condition that we didn't consider in developing our application that created this exposure. And the types of exposure we're talking about here is loss of business through some sort of abuse of a business flow. It could be loss of concert ticket sales or high volume referral purchases or brute forcing incremental IDs to gain access to features and functions and account information and so forth. So there's really an endless possibility here. We're talking about logic flaws that can be exploited. And the example that I want to share with you here comes from Instagram. So on Instagram, if you wanted to reset your password, there's a perfectly good business flow for doing that. But that business flow logic could be exploited to take over another user's account. So let's say, for example, you wanted to take over Taylor Swift's Instagram account. You would go to Instagram, pretend to be Taylor Swift, and say, I forgot my password. And it would send a 6-digit code to the real Taylor Swift, which you would not get. But it turns out there's an API where you can submit your guess. 6-digit code, that's a million combinations, right? So all you got to do is start at 1 and keep incrementing, and eventually you'll hit the right reset code. But there were some protections in place that Instagram had implemented. Number one, there was a 10-minute timeout. So after 10 minutes, you couldn't submit any more guesses, but that's frankly plenty of time to send a million API calls. And there was also a 200 guess limit. At this point, I think this hacker thought they were done. It wasn't going to work. But they tried one last thing. They rotated their IP address. And much to their surprise, they got 200 new guesses. So they could simply keep changing their IP address, making 200 more guesses each time, automate that, distribute it, and get through all million combinations well within the 10-minute timeout. So what is the moral of the story here? We need to think not only of how our APIs are meant to be used, our applications are meant to be used, but also how they can be abused. In this case, with Instagram, there was a perfectly good logic, business logic for resetting your passcode. If I forgot my password, I could use this feature and get access to my account again. But the way it was implemented created its own exposure, its own exploit. Right? And there were a number of things they could have done differently. Number one, IP address really shouldn't have entered into the equation. The number of IP addresses you use shouldn't affect how many times you can guess at that reset code. Number two, 200 guesses, probably too many. 4 or 5 is probably enough, and then expire the code. It's no longer valid. If you've tried more than a few times, that code no longer becomes active. You've got to request a new code. And number 3 would be to stay away from incremental IDs. By making it an incremental or numerical reset ID, you're simply saying to the attackers, the reset code is somewhere between 1 and a million. Good luck. And we know incremental IDs are very convenient for developers, but as you can see, they're also very convenient for attackers, for brute forcing, for guessing at IDs, and so forth. So let's stay away from these incremental IDs as well. And so from a prevention standpoint, we've really got to make sure we train ourselves as API developers, as product managers, as security teams, to not just think about the happy path, how the application is meant to utilize that function, but also the potential for abuse, right? How an attacker might try to manipulate that logic to perform some sort of malicious activity. All right, the next one on our OWASP API Top 10 tour is number 7, SSRF, Server-Side Request Forgery. This is a new entry for the API Top 10 that appeared in 2023. And the goal of SSRF is to trick your server into going somewhere that it really doesn't belong. It involves exploiting URL inputs to make requests to a malicious third party or to access internal resources that external users shouldn't be able to access. And it often involves exploiting flaws in the permissions of your server. leveraging excessive permissions on that server to target another system. The harm from SSRF can be extremely significant. If you're vulnerable to this type of attack, it can create a channel for malicious requests. It can expose internal data and other resources to external users. Examples involve users inputting unexpected values, right? So imagine you have an application where you request the user to provide their LinkedIn profile URL. And imagine instead of giving you something that starts with linkedin.com, they give you something that points to a malware site or to /localhost etc password. If you're subject to an SSRF vulnerability, you might find that server actually going to those locations and returning that data to the end users. Now, it's difficult to find published examples of SSRF exploits, but here's one that will really highlight to you the exploit channel and the potential harm. Okay, this example comes from Capital One, where back in 2019, an SSRF exploit allowed an external attacker to steal credit card applications, social security numbers, and more. And what happened was the attacker exploited a misconfiguration in the WAF, the Web App Firewall, to access highly sensitive internal resources on AWS S3 buckets. In this case, the WAF had excessive permissions and would relay any external requests leveraging those permissions. In this case, the attacker used those WAF permissions to send a request to list all of the S3 buckets it had access to, and then download and decrypt all of that information. In this case, over 30 gigabytes of data was harvested through this malicious request, including over 100 million credit card applications, 100,000 social security numbers, and more, and also resulted in a fine of $190 million. So as you can see, SSRF can really create significant harm, especially creating that channel for external users to access malicious sources or internal repositories. So what do we do to prevent this type of breach? First, I highly recommend you utilize the least privilege model. In this case, the WAF had excessive permissions and it leveraged those permissions to relay requests from an external user. So let's limit what kind of permissions those servers have. Let's not trust any inputs that are coming from users. Put them through an input validation check first. So if you're expecting a LinkedIn URL to be provided and you get something that doesn't start with linkedin.com, then throw it away, right? That's not adhering to the expectations of your application. And then simulate these types of attacks, these types of SSRF requests on your APIs, and see if you actually have those types of vulnerabilities present in your application. All right, next on the list is OWASP API number 8, security misconfiguration. This is really a kitchen sink of standard best practices for running and operating your API servers. You really want to make sure you're handling all the quote unquote blocking and tackling to make sure your servers are properly hardened and patched. You've implemented the right policies and controls. Attackers are going to use bots and other automated tools to scan your sites, your servers, your applications, your APIs, and look for any gaps in these controls. So make sure you're validating these continuously. And here's some examples of the types of best practices you should be implementing. Things like server hardening, unpatched systems, not turning off unnecessary services, not using encryption, not setting header parameters like CORS and rate limiting and HSTS, having insecure cookies, and so on. We actually have a whole course on AppSec University that's dedicated to this topic. It's called Securing API Servers. If you want to learn more about this whole topic, definitely recommend you go check it out. Now, the example I want to share here is from Experian, and it involves not properly controlling access to a highly sensitive API. In this case, Experian, the consumer credit monitoring firm, they created a private API for the exclusive use of their trusted partners so they could look up credit scores of loan applicants and so forth. One of those partners thought it would be cool to create an application where loan applicants could check their own scores. And so they built this application leveraging the Experian API. A hacker found that application and wondered, how is this working? How is this site able to look up the credit scores on any loan applicant? And so they tried the application directly, and they found the APIs, the Experian APIs that were powering this feature. And all it required was to provide a user's name, their address, and their birthday. They probably tried it on themselves, and it worked with no password or credentials or anything like that. They probably then tried it on a family member. They knew their name, their address, their birthday, and it also worked. And maybe they tried it on a neighbor where they knew the name, they knew the address, but maybe didn't know the birthday. And so they just put any value in the birthday field, and it still worked. Turns out, as long as you put any digits in the birthday field, you could put all zeros and it would still work. So by improperly controlling access to this API, the credit records of virtually every adult American was made accessible through this application. So what's the prevention advice here? It's pretty clear, right? You want to do all the standard blocking and tackling, as I mentioned. So make sure you're hardening and patching all of your API infrastructure, enforcing proper headers and policies like CORS, cross-origin resource sharing, HSTS, rate limiting, making sure your error messages are helpful but not revealing. Don't include any information that could help an attacker understand your infrastructure or what types of values are being expected. Prevent things like path traversal and server information leakage, and set up a program to review your security configurations. Make sure there isn't any drift or anything like that. Set up automated testing to look for any changes that were unexpected. And do check out the Securing API Servers course on AppSec University. It's got a lot more useful information. Number 9 is a new entry on the 2023 API Top 10, improper inventory management. And although it's way down at number 9, it's actually one of the most common areas that I get a lot of questions about. Improper inventory management has two main aspects to it. The first is awareness and visibility. Do you know all the APIs running in your environment? And the second is control. Once you know what APIs are running, should they be running? Are they up to date? Have they been retired? Where are they running? Who created them? Do they have vulnerabilities? Are they properly documented? And so on. And you'll often hear about things like zombie or shadow APIs, APIs that are out there running, but no one seems to know about them. Or you might have out-of-date, older versions of APIs that are still accessible. And version control. If you have an API running on yourdomain.com/API/v3, I guarantee you when an attacker sees that, they're going to try v2 and v1 and anything else they can dream up. And often those older versions hang around. They still exist. Maybe you've got a customer or a partner that refuses to upgrade to the latest version. And those older versions don't have the same level of security scrutiny, right? We're not testing them. We're not evaluating them. We're not updating them. So make sure you're properly retiring those old versions. The example I want to share here is from Optus, a large Australian telco provider. Here, there was an internal engineer who decided to create an API that had access to a lot of subscriber information. And that API was made publicly accessible. And there were a number of issues with how they did this. Number one, they made that API publicly accessible with no authentication, no credentials required. Secondly, that API had access to significant amounts of personally identifiable information. In this case, 9.8 million subscriber records, including driver's license numbers, phone numbers, dates of birth, home addresses, and the like. And third, this API leveraged incremental IDs. So in this case, the database used incremental IDs for all of the subscriber records, making it very easy for this attacker to simply increment and harvest all of this information in massive volumes. Now, what they did was they exfiltrated all of this information, 9.8 million records, and what you can see here on the screen is them attempting to extort $1 million from Optus to prevent the unauthorized exposure or sale of these 10 million records. This caused a major outcry in Australia. Even the prime minister of the country got involved, and it really elevated awareness of API risks across the country. And this breach was all made possible because there was an unknown API that got published without any awareness from any of the security teams. So the first thing that I recommend is that organizations sit down, create a cross-functional team involving security, development, operations, compliance, risk, and define your API policies and processes. This is really where governance comes in, right? It shouldn't be possible for a random engineer to create and publish an API and get it out there onto the internet, right? We should have very standardized processes for deploying APIs. Next, you have to know what your API ecosystem looks like. You'll often hear the term API discovery a lot. And unfortunately, I'm here to say there's no easy button here, right? There's not one single thing you can do and you will magically have a complete and comprehensive API inventory. But here are some of the common approaches. There's traffic-based discovery, which basically involves watching the traffic coming in and out of your applications, your environment, and seeing what API calls are flying across the wire. Now, I recommend you talk to your WAF provider, your web application firewall provider, because many of them now have API discovery functionality built into their products. They're already watching the traffic. They can now identify those API calls. Next is code-based discovery. Here we're talking about scanning your code repos to look for any API endpoints that exist there. There's app crawling discovery, which is basically crawling through your application, exercising every feature and function of your app, and looking for the API calls that are sitting behind them. There's dictionary discovery, which is really a brute force approach. There are many published lists of hundreds of thousands of lines long of common API paths. So you can simply run these against your applications and see which ones are present. But one of the methods of discovery that's probably most overlooked is what I call the go talk to engineering approach. I've met many security teams who will tell me things like, we don't know what APIs we've got. And that's understandable. But I've never heard that from an engineering leader, right? They have a pretty good handle on what APIs are being built and run in their teams. It might not be 100%. But by having this discussion with the engineering team, not only will you build a collaboration, a dialogue with that team, you're probably going to get a pretty good sense of what APIs are out there, especially for the most important business applications that are running. I strongly recommend deploying and managing all your APIs in a common API gateway. This is a great way to maintain visibility and awareness, but also to centralize policies and to be able to deploy common policies across your APIs. Make sure you properly retire all your APIs, right? And make sure your clients, your partners all upgrade to the latest versions. And finally, do a periodic audit to make sure you know who's got access to your APIs. There aren't any organizations or users out there that really shouldn't have access any longer. All right. We've reached the last entry of the OWASP API Security Top 10, Unsafe Consumption of APIs. This one is also a new entry in the 2023 edition, and I like to think of this as the reverse of OWASP number 9, Inventory Management, which is focused very much on your internal API environment. OWASP 10 is really all about your external API environment, those third-party APIs that you might be using. Now, most organizations are now integrating with dozens or hundreds of third-party providers via their APIs. And we cannot just assume that because an API comes from Salesforce or DocuSign or Stripe or anyone else, that they're safe and free of vulnerabilities and cannot be hacked. And sometimes it's not even an issue of the API itself, but more about how we integrate and implement it in our own code. An improperly integrated third-party API can lead to data theft, breach, account takeover, and other exploits. And like SSRF, it's hard to find some published examples of third-party API breaches, but here's an example that absolutely highlights how an API flaw in another application can cause harm to you if you're not careful. This example involves Companies House, which is a department of the UK government, where organizations can register their businesses. And in this case, an individual decided to register a business with a name that incorporates a cross-site scripting attack. You can actually see the name here. It starts with a quote and a bracket and then script and source. And this actually leads to a cross-site scripting script. And so this individual registered that long string as their company name. And if you were to pull up this record in the Companies House database, it would actually execute that script. Fortunately, this individual had nothing malicious in mind, and it would simply pull up a humorous alert, but it could have been far worse, right? And it really demonstrated that simply by registering this unique name could actually invoke a cross-site scripting attack. And beyond that, any other sites that were using the company's house data might also be exploited if they didn't do their own input validation. And ultimately, this individual was forced to rename their business, which you can still search for and find on the company's house website. It's now called That Company Whose Name Used to Contain HTML Tags, Ltd. So what should you do about third-party API risks? First of all, know what third-party APIs you're actually using. This can be a little tricky as you might not find those APIs in a code repository or an API gateway or some central repository like that. Second, do not assume that third parties are inherently safe and trustworthy. Right? Just because you're utilizing an API from someone else doesn't mean that they are perfect. That means treat them like your own APIs. Do your own input validation, test your own authorization rules, make sure user A can't see user B's data or any other cross-account contamination or any other OWASP vulnerability for that matter. And why not ask your third parties to demonstrate their own testing, show you their API pen testing reports and what are their programs for making sure their APIs are safe and secure. And you can also do your own API testing. Just make sure you check your license agreement and don't violate anything. But we strongly recommend you test those APIs just like you would your own APIs. And that wraps up the OWASP section of this course. We've gone through a lot here. We've gone through all of the top 10 threats to APIs. We've given you 10 examples to reinforce it. I'm hoping you can see clearly that API risks are not theoretical. The OWASP top 10 for APIs exists for a good reason, and the OWASP community did a really exceptional job developing these. You can see these threats are resulting in significant real-world breaches. In the next section, we're going to examine these threats further and help you develop strategies to defend your APIs. All right, now that we've covered all of the OWASP top 10 and explored a number of real-world examples, we're going to shift gears now and look at what's behind all these threats and what you can do to better protect your APIs. In this section, we'll analyze what the most common attack patterns are and cover risk and threat modeling as well. You might remember this API breaches slide from earlier in the course. And we wanted to analyze all these breaches to see if we could find if there were any common patterns to these attacks. We looked at each example and identified what the root cause or causes were for each of them. And it turns out there were some attack patterns that really stood out. And here's what the data looks like. Right off the bat, you can see that these top 4 categories really dominate how APIs get breached. And right at the top is rate limiting. Almost 70% of those attacks on the last slide involved some form of high-volume brute forcing of the application. Anytime we see millions of records being breached, that suggests that there's some sort of high-volume attack that's succeeding. And you might look at this and conclude that the number one thing that we have to improve is better bot detection and rate limiting. And I actually think that's the wrong conclusion. Rate limiting is not the cause of a breach. It's really more of a defense mechanism. We use rate limiting to try to defend against high volume attacks, to prevent bots and so forth. We use rate limiting to try to prevent this kind of mass harvesting. And what this chart highlights is this defense mechanism is not perfect. A determined attacker can find their way around rate limiting and other defenses. How? First, they can find out where your rate limit threshold is, and then just dial it back by 5 or 10% and leave it there. Second, they're going to distribute their attacks across thousands of IP addresses. They're going to use residential proxies and other methods to evade detection. The main point here is, while you absolutely should use rate limiting, don't expect it to be a perfect defense and block all high-volume attacks. You got to remember, your WAF has only a few milliseconds in order to decide if a request is valid or not, while your attacker can take months to execute their attack and exfiltrate all their data. And as I mentioned, rate limiting isn't even the core issue. If your API wasn't revealing something of interest, something of value, maybe some PII data or other valuable information, the attacker wouldn't even bother sending 500 million requests, or even 50. So if the core issue isn't rate limiting, then what is it? And it turns out actually the next three items on this chart, which are OWASP 1, 2, and 3, are the primary causes of API breaches. They're actually responsible for 90% of all those attacks on the last slide. And it really shows how the OWASP community did a fantastic job identifying the top threats to APIs. And what are we talking about here? OWASP number 1, broken authorization. Can user A access user B's data? We saw a ton of examples of this, from Duolingo to Peloton to Trello. OWASP number 2, broken authentication, right? We're not even talking about brute forcing passwords. We're talking about APIs left with the door wide open. We saw a lot of examples of unsecured APIs that allowed unrestricted access to those APIs. And OWASP 3, excess data exposure. This is really key. Is your API returning some data of value, of interest to an attacker? If I can access my Duolingo records through the API, that's probably okay. If I can access your Duolingo records, now you got a breach. And this is really a combination of OWASP number 1, broken authorization, with OWASP 3, excess data exposure. So what this all means is if you can really address OWASP 1, 2, and 3, you can make a huge impact in the security of your APIs. In fact, this is why I think it's so important that we make this type of training and awareness available not only to our security teams, but to our developers as well. I've done talks on this to engineering teams where I've had developers raise their hand at the end and say, I already know code I got to fix. So let's make sure that we make this training available to everyone who needs it. All right, now that we've identified where the top sources of API risks are coming from, where do we go from here? And most security frameworks out there, whether it's NIST 800-53 or ISO 27001 or plenty of others, they all start with doing a threat modeling and risk assessment. Figure out where your weakest links are. And I work with many organizations, and I typically start with these two questions. The first is, why do you care about API security? It's a simple question, and you should take a minute or two to really think about what your answer is in your organization. And here are a few sample examples. These are not the only ones. You got to figure out what your answer is. But you might say, we care because it's the right thing to do, right? We've got your sensitive PII data or other information, and we have responsibility to protect it. That's a valid reason, right? Or you might say, we have to address API risk because it helps protect the company. It reduces the potential harm. Or you might say, we just have to do it, right? We have compliance or regulatory requirements, right? The auditors make us do it, right? So just make sure you have a really honest conversation with yourself, with the organization about what are the drivers. But the next question is critical. How important is this to the business? Most people I talk to will say APIs are critical to the business. They're important to keep secured. These people understand the risks of APIs and what the potential harm is, but does your business feel the same way? And the way you're going to know this is by asking questions like, is API security a priority in my organization? Right? Most departments will set goals and priorities for the upcoming year, for example. Is API security on the list? If it's not, then that really questions how much of a priority it is. Are you getting the resources, the budget, the manpower to be able to really tackle API security properly? And why now? What are the compelling drivers to say we got to address API security now and not sometime in the future? As I mentioned, most frameworks start with a threat modeling exercise. These methodologies typically follow a pattern something like this. Starts with identifying your footprint, your attack surface area. This includes not only the APIs themselves, but also the business flows, what function the APIs provide, how they're accessed, and so forth. Then you need to examine these and identify vulnerabilities that might exist. Any logic flaws, gaps in access controls, risks from third parties. Next is to understand the likelihood of an attack on that asset and the potential impact. What would happen if this vulnerability were successfully exploited? Would we lose customer data or just a database of past weather records, for example? And then based on this analysis, how are we going to mitigate any high-risk threats? I recommend you start this analysis with an exercise around what do you have that attackers want? Attackers are interested in lots of things, but what do you have that they're interested in? It could be personal data. Collecting PII is always an attractive target. This data can easily be sold on the dark web. It's what makes phishing campaigns possible or identity theft. Or maybe it's banking information, credit card details, and so forth. Or corporate data, IP, could be espionage, collecting other sensitive corporate data, research and lab work, and so forth. It might be fraud, right? Exploiting your service to steal goods, steal money, steal services. Or if you're involved in critical infrastructure, right? Whether it's energy, communications, healthcare, banking, or other critical infrastructure. Maybe the motivation is activism, terrorism, mayhem, and so forth. But you got to figure out what it is that you've got that an attacker will be attracted to. Next is to understand how are you using APIs in your business, especially with an eye towards those APIs that might be used to access some of that sensitive information we were just talking about. Almost every website and mobile application these days is powered by APIs. Do those APIs have access to any of the stuff that we just talked about on the prior slide? Can those APIs be misused or abused to cause some form of harm? Most organizations are now even exposing APIs to trusted customers, to trusted partners, or even to the public. And with containers and microservices, APIs are really the universal language for communicating among these internal services, right? You're also probably using APIs provided by third parties. Which ones are you using and for what purposes and what information is being passed along? The goal here is to understand where APIs fit in the landscape and where the holes or gaps might exist that can potentially be exploited. Okay, having done that homework, now we put it all together, right? Threat modeling is almost always a formula that looks something like this. Risk is a function of the threat, what kind of attack, times, the vulnerability, right? What type of exploit or weakness are they going to try to take advantage of? The likelihood of such an attack happening, and the impact if such an attack were successful, right? So take the threats that you identified on these last few slides and then evaluate each one against these dimensions. And here's what that exercise might look like. Let's take unknown APIs, right? This is a very common worry that security teams have, right? The zombie rogue APIs that no one knows about. What is the vulnerability? There might be unknown APIs out there, and those unknown APIs might have vulnerabilities that can be exploited. Okay. Next, what's the likelihood? Well, an attacker would A, have to have discovered those APIs, and B, have to find some sort of exploit or flaw in them. So you've got to assess what's the risk, low, medium, high, or whatever it might be. Then you have to consider the impact. So suppose an attacker did find an unknown API. What could the impact be? Probably could be very significant. You don't know. Take the Optus example from earlier, right? There was an unknown API that in this case had access to 10 million subscriber records, and clearly the impact was very significant there. But really, this is just meant to give you a feel for what a threat modeling exercise should look like. So now you multiply all of these factors together, and it should give you a way to prioritize which risks are most present in your organization and take us to the next step, which is building out a mitigation plan. Okay, now that we've got an idea where our top risks are, next is to figure out what we can do about them. And this is where we'll introduce the 3 pillars of API security: governance, monitoring, and testing. And we'll dig into each one of these individually. But at a high level, governance is all about defining and establishing and enforcing standard processes for developing APIs, testing APIs, getting them into production in a secure and consistent way. Monitoring is about runtime protection, protecting our APIs in production, making sure they are behaving as expected, there aren't any attacks ongoing, and other anomalous activity. And testing is all about making sure your APIs are free of vulnerabilities, that they perform as expected, and there aren't any flaws that can be exploited. So let's focus on governance first. The goal of governance is to establish consistency. Consistency in how your APIs get developed, how they get deployed, how they get tested, and everything else. It's important to set expectations for your engineering team in these governance policies. What's expected of your development teams when they're creating and publishing APIs? What are the documentation requirements? What are the authentication policies? How do we version our APIs and retire older APIs? It's about establishing standard processes for how APIs move from development into production in a consistent way, and enforcing security to make sure that nothing moves into production that hasn't gone through the same level of security assessment and vetting. There are two core components to governance. There's the awareness side, which is all about having proper visibility in what APIs you have. What infrastructure are they running on? What data do they have access to? And what risk do these APIs bring along with them? And then on the other side, you have policy and process, which is about how do we go about developing our APIs? How do we deploy them? What documentation is required? What are our design and style guide requirements? And so forth. So let's dig further into the awareness side, right? This is all about knowing your APIs, right? Getting a full inventory of all your APIs. Why do they exist? Who owns them? Are they documented? What function are they performing? Where are they running, right? Do you have a comprehensive view across all of your APIs, right? And you don't just want to know what APIs, you want to know the infrastructure, the app architecture, the containers, the virtual machines, what databases are they connected to, the network infrastructure, and really have a good understanding of how everything interconnects, right? You want to standardize your deployment processes so that all APIs only get deployed in approved ways with proper validation. Nothing gets out there without following the process, right? No shadow or rogue APIs, as you've heard it called. And frankly, if that's happening, that's a sign of weak governance, right? There should be no ability for APIs to get into production without your knowledge, without going through these proper channels. Now, the best way to enforce this is through the use of an API gateway, right? So you have a central control point where all APIs are being managed and that they're going through proper validation steps. And we have to make documentation mandatory. The whole point of having APIs is so that other consumers can use them, whether they're other developers inside our organization or external parties, right? This documentation is what allows them to know what your API does and how I can use this. But this documentation is also critical for security. But we run across way too many organizations where documentation is missing, it's patchy, it's out of date. So really strongly recommend that you make documentation of your APIs mandatory. This is a foundation of having good governance. And then create your API development standards so that every engineering team, every development team creates APIs in a consistent standard way. And I'm talking about style guides, design guides, and the like. We'll talk more about that a little bit later. But let's talk some more about documentation as it's so important, right? What do we mean by API documentation? Well, the most common format out there is the Open API specification. You might hear it called OAS, or it used to be known as Swagger. This really is the industry standard for documenting REST APIs. It's typically in a YAML or JSON format that can be read by machines. And if you're publishing your APIs for external use, you want to make sure you're controlling what information you're making public. Right? There are very easy ways to find these specifications on the internet. Clever Google searches can turn up your Swagger files, and attackers are looking for them. Right? We find a lot of API specifications published on wide open internet sites. Right? It might be necessary. Maybe you need your API documentation to be publicly available. But if possible, I definitely recommend making external users have to register, get validated before you give them access to those documentation. So make sure you're only publishing what needs to be out there and control access as much as you can. Now, the documentation itself is going to define everything about your API. The functionality of the endpoints, the description, where the API exists, the base URL, the endpoints, payloads, authentication requirements, parameters, data types, methods, all of that is captured in this documentation. And you want to generate this documentation, this specification, as much as possible through automation, right? You can write it by hand, but if possible, we recommend that you auto-generate this so that this documentation stays fully up to date. Instrument your code repos to automatically generate this specification, insert the necessary comments and details into the repos to make sure the documentation comes out as complete as possible. And let's take a look at what this documentation actually looks like. Here you can see an example. On the left-hand side is the raw YAML or JSON of a Swagger file or an open API specification. There are documentation parsers that'll take this and make it human readable. Some really great ones out there. I recommend you check out swagger.io. They've got a cloud-based tool for parsing and visualizing your API docs. And this will help the consumer of your API understand in plain English with visual interfaces what your API does. Right? But over on the left-hand side, you'll see what the machine-readable version looks like. And we recommend that you take time and define and publish your own API style guide. Right? This is your organization's set of standards and conventions for how APIs get built. And it helps us make sure that all the APIs that get created in our organization look and feel the same. Right? It'll cover things like how you authenticate users, right? What type of authentication, when and where you use different kinds of authentication. It'll cover authorization, who can access what and under what conditions with what permissions. It'll even cover things like naming conventions, like you typically want your URLs to be nouns and the methods to be the verbs, right? Whether you're posting a new record, putting in a new value, deleting an object. It even covers things like pluralization, hierarchy, language. Stay away from jargon, of course. Your error codes should be defined in your style guide as well. These should include status codes, reference IDs, human readable messages. But make sure that those messages aren't revealing useful information that could help a potential attacker. If you got an error code, you might want to say rejected, denied, improper input, or something like that. But you don't need to go further and say expecting an 8-digit integer or something like that. That's just helping out your attacker. The style guide will cover versioning, when to increment, when not to, how to retire, units and standards, and so forth. So I looked around and actually found this site on Atlassian. They're well known for having outstanding API documentation and style guides. Here's an example of their design guide for authentication. And what you see here is every REST API must have, at minimum, basic user authentication. Authorization is not handled at the API layer, right? It's the responsibility of the application itself. That's all defined right here in the design guide. And similarly, we have a section on versions. It covers when do you need a new version, when you don't, what happens to the old versions. These are all the kinds of things that you should be thinking about and factoring into your style guides. The second pillar we're going to go through here is monitoring, right? And this pillar is all about understanding how your APIs are performing and operating in production. And I like to think about monitoring in 3 buckets: runtime protection, threat detection, and control validation. So let's start with runtime protection. This is the active real-time protection of your APIs. And the elements here include things like policy enforcement, like requiring authentication of users to access certain endpoints, filtering traffic. Maybe we need a geographic traffic filter, or we're only expecting traffic from a certain region or IP range. That's an aspect of runtime protection that you can implement. The next category is threat detection, right? How do we analyze the traffic to look for things like fraudulent transactions, fraudulent traffic, distributed attacks coming from lots of different sources, or that are targeting similar resources, and that you want to be alerted to and make sure you're controlling properly. And it also enables incident response, right? You can capture all the traffic, log it, put it into a repository, and then retrace the steps to understand what exactly happened. And finally, then implement the appropriate mitigating controls to prevent future attacks. And then finally, you want to validate the controls that you have in place to make sure they are working properly at the gateway, at the firewall, at the application itself, that these controls are functioning as designed, that there aren't any surprises happening in production you weren't expecting. You're not finding any anomalies or unexpected traffic from going unnoticed without the proper controls. Now, there are really 2 fundamental approaches to runtime monitoring. There's proactive blocking, which you'll find with things like a gateway or a web application firewall. Here's where you can actually enforce policy actively, right? You can define in the gateway that certain endpoints are only accessible with valid authentication, and the gateway actually can perform the authentication itself. Or with a firewall, you might want to implement rate limiting or IP whitelisting, and that the traffic that doesn't match gets blocked actively. The other side is more reactive, like an alerting mode, right? For monitoring here, you probably want to capture all the traffic, log it, put it into a SIEM, a security information and event management platform, or a log management solution, or a runtime API threat management tool. The issue here is you may not have enough context in order to make judgments about whether the traffic is legitimate or not. So in this case, you want to get the alerts, you want to be notified, you want to be able to retrace the steps, because the last thing you want to do is start blocking legitimate traffic. And there may be instances where there's just simply not enough context to make a yes/no decision. So then implement alerting and the ability to go back and understand the traffic and maybe refine the rules for your inline proactive technologies. Another benefit of monitoring is API discovery, to actually watch what's happening on the wire, on your network, and identify APIs that are in use active on your network. Right? This can be useful for generating your API inventory, for discovering APIs that were unknown, for finding undocumented and unknown APIs, for generating API documentation, and so forth. But you need to be aware that this is not necessarily going to give you a complete view. Right? If your goal is a comprehensive inventory of all your APIs, which frankly it should be, then you need to look well beyond network traffic monitoring. This is because APIs may exist inside your network or in cloud segments or other areas that your monitoring tool just can't see. Right? So you should be scanning your code repositories for APIs, crawling, doing other forms of app testing, communicating with the dev team, and so forth. That's how you're going to get a comprehensive view. Let's dig into the key challenge of monitoring-based approaches for API security. If you recall from that slide we showed earlier with all of those API breaches, I guarantee you every one of those organizations were using monitoring tools, they were using bot detection, firewalling, SIEM, WAF, and others, right? And still those API attacks got through. And the primary reason why is API attacks look like legitimate traffic. Let's look at a couple of examples to make this point. The first example I want to show you here is clearly bad, right? We see a GET request to user ID equals blank or 1 equals 1, right? Now, this is very clearly bad. This is the most basic SQL injection that there is. And 1 equals 1 is going to return true for everyone, for every record in this database. And if you're vulnerable to this type of injection, it's going to return your entire user database. But there are many ways to prevent this, and your WAF, your web app firewall, is absolutely going to be able to detect it and block it. This is clearly bad. There's so many ways to prevent it. But now let's look at this next example, right? We see a request from user 10, and let's assume that user 10 is properly authenticated. They've got valid credentials, and they're running a delete request on transfer 123. Well, everything about this request looks legitimate. The user is valid. They've got proper credentials. Delete is a valid method. Transfer is a valid endpoint. And 123 is a valid transfer ID. Everything about this looks legitimate. But imagine now that transfer doesn't belong to user 10. It belongs to user 11. And suddenly this request is no longer legitimate. It's completely malicious. And that is what's missing from most runtime protection solutions, right? They don't have that kind of context. And your WAF has a few milliseconds to review this and make a decision whether to allow it or not. And this is the fundamental challenge of runtime solutions. It's having enough context to understand if that request is valid. Take the Coinbase example from earlier in the course. The WAF doesn't know if the user is making a request to sell Bitcoin they own or Bitcoin they don't own, right? And this is the fundamental challenge with API security monitoring. Now, don't get me wrong, right? It's absolutely critical to use tools like gateways and web app firewalls and other monitoring tools to protect your APIs, to get alerted on anomalous traffic, to attempt to block these bot attacks and high volume attacks, right? Just understand that these tools are not perfect, and a determined attacker can often find a way around them. And that's why it's so critical to complement monitoring with really comprehensive continuous testing, which is what we'll talk about next. And moving on to the final element of the 3 pillars of API security testing. We mentioned this early in the course, but our APIs are seriously under-tested. Right? We shared a survey from Nokia/Rapid API, where only 4% of respondents indicated they were doing security testing on their APIs. And here's what the full breakdown of that survey looks like, which is the vast majority of testing organizations do is positive testing, right? Does the application work as designed? Does it function? Is it free of bugs? Is it fast? Does it integrate? But as security teams, and frankly, as developers and product owners, we also need to think about negative testing. Does the application not do what it shouldn't do? But as you can see, only about 4% of organizations out there responded that they are proactively testing their APIs for security flaws. So let's break this down and talk first about what kinds of testing should we be doing, right? And I've broken this down into 3 categories, right? Security testing, data testing, and logic testing. At the lowest level, I'd say, is security testing, right? Here we're looking for things like unsecured endpoints, right? Are we leaving the door unlocked? And you saw tons of examples earlier on from Peloton, Duolingo, and others where the APIs were just simply left wide open. Anyone could access them with no credentials, right? Next, we've got things like, are we using incremental IDs that make it easy for brute forcing or harvesting information? Are we running injection scenarios and cross-site scripting? Are we doing fuzzing tests and input validation tests and so forth? Next, we've got the data category. And here we're really focusing on what kind of data is your API accessing? What kind of data is it returning? Is there sensitive information in here? Is it too much information? Can we filter it down and return less information and still meet the business requirements? Are there regulatory implications for this data? Then we have at the highest level, the logic tests. And this is probably most challenging. These are your unique vulnerabilities, if any exist, right? And these are the types of things that will not get captured in classic static code analysis or a dynamic application security testing tool. And here we're talking about things like cross-account access, right? Can I access other users' records? This is number 1 on the OWASP top 10 list. BOLA, broken object level authorization. Object ID manipulation. Can I sell my Ethereum as Bitcoin? Function abuse. Can I elevate my free Bumble account to a paid account, and so on? And what this slide really reveals is the testing challenge, which is how on earth am I going to cover all of these different scenarios? How can I get this kind of coverage efficiently? Most AppSec teams don't have time and headcount to sit and create all of these attack simulations. How do we make this testing continuous, not just a once a year exercise or sporadically or as needed? And lastly, how do we integrate and automate this kind of testing and shift it left so that we find these issues before they ever make it into production? Now, what we've found in working with hundreds of organizations across the globe is that there really are 3 primary approaches to API security testing. And unfortunately, the first approach is do nothing. This is probably more common than we'd like to admit. For some reason, APIs have been this elephant in the room that many organizations have ignored. But as you've seen, attackers are not ignoring them and absolutely exploiting vulnerabilities in APIs. There's still a perception that APIs are hidden and undiscoverable and therefore not at risk. But we all know that's not the case. The second option is to do it yourself. This is quite common. And here we're talking about having members of the team, pen testers, offensive security, red teams, sit and create their own API attack simulations. And there are some really fantastic tools out there to help you do this. Tools like Postman, Burp, Zap, that are very, very popular and extremely powerful. But they also require a high level of expertise. You have to really know how to use these tools. You have to know what kinds of attacks you want to simulate. And ultimately, you need an awful lot of time in order to create and set up these types of testing regimens. And the third option is to pay someone else to do it. i.e. third-party pen testing. And the issues here are, number one, most organizations only run pen tests once a year. And meanwhile, they release code updates every month, every week, even every day. They don't test every single API in their environment. There are just far too many to hand to your pen tester to cover. And third is you typically give your pen testing firm a week or two to go and do their assessment. They come in, they do their best, and they give you their report and then disappear for another 12 months. And you're very much at the mercy of how good your pen tester is. You might get a Corey ball and you might not, right? So each of these approaches has its own very real challenges. So we wanted to make a fourth option, which is to automate API security testing as much as possible. And that's why we created APISec, our automated API security scanner. You don't need to be an API security expert. You don't need to have a lot of time. All you need to be able to do is provide your API details, whether it's a specification file, a Postman collection, or even just integrate it right into your gateway, and it will auto-generate thousands of attack simulations covering all of those OWASP categories. And since it's automated, it can be continuous. You can integrate it right into your CI/CD pipeline. If you're doing nightly builds, you should be running your security testing nightly as well. But the main point I want to get across here is that we need to significantly improve our testing, make it continuous, shift it left, and there are technologies out there that'll help you get there. All right, our final section here in the API Security Fundamentals course is a review of the application security technology landscape. Now, the cybersecurity market is a pretty huge market, and I'm not going to go through all of this because there's just way too much here. But there are many, many facets and aspects to cybersecurity. But what we're going to focus on here is application security specifically, for which there are also many sub-technologies. You've got static code analyzers, dynamic testers, software composition analysis, container security, web app firewalls, web scanners, and more. These are all very well known and widely deployed technologies. But the reality, as you've seen, is with API breaches, this is a new class of risk, a new attack vector that's targeting APIs, and they're being successful. And that is revealing that we've got a gap in our security technology coverage. When it comes to API testing, most people first think about their existing legacy application scanners, right? Things that are known as SAST and DAST, static application security testing, dynamic application security testing. These are very mature technologies, been around a long time, widely used. But the key is these technologies look for common vulnerabilities. You might have heard of CVEs, common vulnerability entities. That's how we categorize these types of flaws, right? But APIs rarely get exploited via common vulnerabilities. Why? Because these common vulnerabilities are easily detected and fixed. It's very rare for organizations to get breached through a SQL injection attack or a cross-site scripting. What attackers are looking for are your unique flaws, your logic flaws, gaps in your authorization rules, other ways to abuse your API functions. And my colleague, Corey Ball, the author of Hacking APIs, the co-creator of APISec University, he puts it really well in this interview. Most web API flaws are missed by standard security tests. And that's right? If you're running a Nessus scan for your web apps, for example, that's great, but don't think that you're covered for all of your APIs. APIs require a deeper level of customized testing. So let's look at the lifecycle of an application and what security tools and processes you can implement along the way. What you see here is a very simplified pipeline from developing technologies all the way through to operating them. And we strongly recommend you incorporate security as far left in this diagram as possible so that APIs are highly secure before they ever make it into production. And it starts at the API definition phase. Here's where you're sketching out your API, you're sitting at the whiteboard with the rest of your team, and hopefully security is in the room, right? Or someone who's aware of security concerns, right? You want to be thinking about, what does this API do? What data is it going to access? What are the security implications here? How can we mitigate risk? What kind of controls do we need to have here? So once you've got all that spec'd out, you move into the development phase, the coding phase. And here you're going to do your regular things like code reviews. You're going to run your static code analyzer, your software composition analysis. But your best bet here for finding API flaws is in those code reviews, right? That's where you're going to be able to think about and address potential issues, right? But maybe there's a flaw in your application logic that gets missed in the code reviews and it makes it through to the next phase, which is testing, which we've talked a lot about. You've got a number of choices for API testing. You've got your legacy DAS tools, manual testing, external pen testing, or hopefully you're automating your API-specific security testing. It's critical that we find and fix vulnerabilities here because this is your last step before your APIs are now live and in production. And then you've got to rely on your runtime technologies like firewalls and gateways and SIEMs to be able to identify and block attacks as they're happening. And finally, when you no longer need that API or you release a new version, make sure you're removing any old APIs that don't need to be out there. So let's bring this all together and help us map out a game plan for remediating our highest API risks. Earlier, we reviewed how and why to perform threat modeling around your APIs. So let's overlay that with the application lifecycle to figure out where we can address those risks. And here are a few examples for illustration, right? Things like unknown APIs, unauthorized account access, data harvesting. So you want to look at all of these risks and how you're going to mitigate them and where. So let's take unknown APIs, right? You could tackle that up front by having some process or policies that mandate that all APIs get categorized and inventory in a gateway or an API marketplace, right? Or you might use your web app firewall or some runtime detection tool to detect and discover APIs as they're being used. Take unauthorized access, right? This is something you can address during the coding phase by implementing the right controls to prevent any cross-account access, for example. Or you might implement testing that specifically simulate these kinds of scenarios to identify any authorization gaps that you might have. And what you'll end up with now is a fully prioritized list of all of your risks and a plan for how and where to mitigate them. And all things equal, try to address these issues as early as possible. Okay, and that wraps up the API Security Fundamentals course. I want to conclude with a few final thoughts and some best practices. But let's start first with some common sources of risks. I've met with hundreds of organizations, and here are some of the common issues people have with APIs. And the absolute most common concern I hear is API discovery. And organizations are really struggling to get their hands around all of their APIs. And that's understandable considering how pervasive APIs are, right? You could literally have thousands of API endpoints, even at a small organization. Shadow and rogue APIs are definitely a real thing, and you should absolutely find and manage these. Now, the next biggest issue we hear about is vulnerable APIs. This also makes sense, right? We know APIs are the pathway to our internal data and our internal applications and functionality. And as we've seen, flaws in how APIs are developed, encoded, and configured can lead to exploits and breach. Next is weak runtime defenses. Security teams tend to gravitate to products and technologies that can be implemented in production that will keep our companies safe. Unfortunately, there's not really an easy button here, right? And we need to make sure we're using those runtime solutions properly. Third-party APIs is definitely a source of risk as well. You got to know what APIs you're using, how you're using them, and make sure they're being used properly. And the last two that you'll see here are really more about process than technology. Weak governance reflects a lack of having a strict defined API development and operation set of policies. And organizations that get this done really well are those that think about APIs as products themselves. They literally even have people with API product manager titles. This helps ensure that your APIs have the same level of attention and scrutiny and processes as the rest of your products. And lastly, poor collaboration. And here I'm talking about the partnership or maybe the lack of partnership between the security teams and the development teams. One thing about APIs is if there's a flaw, it probably can't be fixed with a new firewall rule, right? It very likely is going to require some involvement from the engineering team. So building a strong collaboration between these organizations is absolutely critical. And all right, here's my last slide of the course, an AppSecU top 10 list of our own. It's our top 10 do's and don'ts. The first is don't trust anything. We've talked about this a number of times throughout the course. Don't assume that whatever the user is inputting is valid. Assume it's not. Which brings us to number 2, which is to validate all inputs, right? So make sure that the parameters, the inputs that are coming into your APIs match what you're expecting. And if it doesn't, throw it away. Could be malicious. You should definitely not be processing it. Don't reveal useful information in your error messages. Remember, your error messages should be helpful, but not revealing, right? If you need to say a user isn't authenticated or an input isn't valid, that's enough. You don't need to go further and say, we're expecting an 8-digit integer, right? That's information that does not need to be shared. Do expect that hackers are going to find your API endpoints, even those undocumented ones, right? Don't fall for the myth that APIs are hidden, they can't be discovered, and you don't need to worry about them. Just remember all those breaches that we talked about earlier with those APIs that were left totally wide open. Don't have hidden or unadvertised features. I was talking to one organization where they literally have a published API and a set of unpublished APIs, and they acknowledge that users are going to find them. Don't do that, right? Don't leave it to your users to figure out what your APIs are, what they can do, and start getting creative. Don't filter data in the UI. That is not the job of your UI. That's the job of your application. The application itself should be controlling what data is coming out. Your UI's job is simply to present that information, not to perform enforcement or controls or filtering. Do use an API gateway to control traffic and really centralize your API management. All your APIs need to be controlled and managed in a consistent way, right? Make sure you're controlling what's accessible, how it can be accessed, who can access it, what functionality is being made available. Don't forget or confuse authentication with authorization, right? Authorization is about what can Dan do? What data can he see? Whose records can he access? Your application needs to control what I can see and under what circumstances and with what permissions. Do definitely require API documentation. I can't enforce that enough. This is an absolute must. Make sure your APIs are properly documented and that documentation is maintained and kept up to date, right? This isn't just critical for internal use or for our external consumers, but it's also critical for security as well. And finally, do continuous testing on every release, every push to production, simulate attacks, look for authorization gaps, logic flaws, unsecured endpoints, and every other type of scenario that we talked about here. And with that, I want to thank you for taking this course. I really hope you enjoyed it. I hope it raised your awareness of API risks and what you can do to better protect them. And so what's next? First of all, I invite you to go earn your badge and certificate for completing the API Security Fundamentals course. As members of the freeCodeCamp community, you can get your badge by visiting appsecuniversity.com/freecodecamp, where you can register and take the final quiz. We'll issue your badge and certificate directly. And one other thing, we also offer API security workshops. These are private 1-hour presentations that I give to help raise awareness about API security risks and best practices for your organization, right? There's no charge for these sessions, so just let me know if you'd be interested in setting one up. All you have to do is go visit appsecuniversity.com/workshop, and you can request a workshop there. So thanks again for making time to take this course. My name's Dan Barahona, and I welcome you to be in touch and connect with me. Feel free to reach out if you've got any questions or want to discuss any of this content in more detail. And please check out our other courses on AppSec University. Thanks a lot and take care.